We're really lucky today. We're joined by John Cause for short. He's the co-founder of Pure Storage. His journey in storage is quite remarkable. He spent around 20 years at Veritas Software, where he became one of the industry's experts on optimizing data structures for rotational hard drives. He was the primary architect for the hugely successful Veritas Volume Manager and file system. Anything else I should add on your time at Veritas?
No, clearly that was bio written.
So we'll be learning more about that. So 2009, he made a bet that would reshape enterprise storage. So his bet was that flash storage would eventually overtake disk and offer cheaper total cost of ownership and better performance. Today, Pure Storage has grown into is it 30 billion market cap?
Yeah, about that.
Around that company, so congrats, Cause, on that. And we'll spend time today really exploring Cause's journey, Pure Storage's work in government, and also their role in the current AI revolution and what's to come next. So Cause, thanks for joining us today. So maybe we could start just back on founding story. I believe around 2008, you joined a venture firm called Sutter Hill Ventures as an entrepreneur in residence, and you were observing the growing acceptance of solid state storage. What was the specific sort of aha moment that convinced you that flash would revolutionize enterprise storage?
I'd been in Veritas for 20 years almost, and I really enjoyed storage, always did, but I got kind of tired. And so I retired and built a house. When I say I built a house, I'm software by background, so I didn't hammer in any nails. I had a builder and an architect for that, but you got to pick everything for the house. You got to do a bunch of stuff. And after a little while not working, I realized that I wasn't ready to be retired, and I wanted to go do something fun and exciting. And I decided startups are fun, so I'll go talk to a friend at Sutter Hill Ventures and join them to look for a startup. And I'm an engineer by background. I wasn't thinking, oh, I'm going to start a company. My original thought was I'll find a startup doing something cool. Maybe I'll go consult with them for a couple of years, then I'll go find another one, and venture firm's a good place to do that. And of course, when I walked in the door, they're not thinking, hey, you're going to go join some startups that we're doing and consult for them occasionally. They're thinking you're going to go start something big. One of the first questions that Mike Spicer asked me was, what's something that's going to completely change the data center? And at Veritas, they're now 70 years old. And just even think about that in the high-tech world, how many things do you use that are really anything remotely like 70 years old? But after decades of just getting so much cheaper, so much faster, so much more reliable year after year after year, they slowed down. They stopped improving their performance around 2001. And then around 2007 or so, you started seeing them not get cheaper and bigger at the same rate. So their rate of improvement had slowed. And that left the door open for a new technology. The first time somebody ever told me some tech was going to replace a hard drive was early 80s. It was a professor at the University of Colorado who, I was working at Bell Labs at the time, and she came and was chatting with us, and she's like, oh, we have this new technology, and it's going to be way bigger than hard drives and way faster, because you're never going to be able to get a hard drive bigger than a couple hundred megabytes because of the paramagnetic limit. And we clearly have them bigger than a couple hundred megabytes, because a couple $1 billion a year of R&D builds a lot of improvement. Now that technology, by the way, was CDs. So CD-ROMs, which became a replacement for floppy drives in the end, were that first technology. I mean, trying to overcome a technology that is improving the way hard drives were, the way processors were for ages, it's really hard, right? Because you've got something in the lab, but you're chasing a moving target, and that moving target has just got so much more money behind it. So I saw an opportunity. Now, the other thing that was necessary for that opportunity was basically smartphones and other personal devices. So if you think about it, your phone, your iPod, for those of you that remember an iPod, none of you, I guess, your personal devices, they put flash in it because it gave you better battery life, more resistance to shock, so if you dropped it, it didn't break, and the higher cost of the flash didn't matter. So now you had flash at the same kind of exponential economic improvement as hard drives, and the flash is just better, right? If I give you a flash drive versus a hard drive for the same price, you're like, of course I'm going to take the flash. It's like 1,000 times faster, it's lighter, it uses less power, it's more durable. It's like, why not? And so that was really the key, was just seeing that you could get to approximately the same economic scale. And so I realized that that was the right time, and so ended up starting Pure.
Yeah. So when you started Pure, the industry was also dominated by incumbents like EMC, HP for more than 30 years. Like, how were you confident that Pure could compete and be better than competitors?
Well, the advantage any startup has is it's really focused and it moves fast. And you don't have to solve the whole problem day one, right? And that's something to realize. Like EMC, they're trying to be everything about storage to everybody. So at Pure, hey, the flash came in and started competing with the performance-oriented hard drives. And we didn't worry about the rest of the market. We just worried about that one narrow focus, and we worried about just a couple of focused use cases. And our sales teams, when they got around to selling it, they took it a whole bunch of places we never dreamed of at first, or that we thought were years in the future. But it's really all about speed and focus, and that's the way anything works, right? I mean, you have two armies fighting, and one has a very narrow point of attack. It's like all the soldiers that the other one has that aren't anywhere near there don't help, right? We had a very focused attack, and that's what carries the day.
So everyone here is familiar with In-Q-Tel, U.S. government venture firm, since we've had some In-Q-Tel representation at this seminar earlier this quarter. So I think you were In-Q-Tel's first ever investment in a flash storage startup. Can you maybe share how that partnership came about, and what did you have to demonstrate to really earn the trust of the intelligence community?
So we started selling our beta units. We started the company. We did a first couple of prototype alphas that looked nothing like the real product. Were just designed to demonstrate the key technical things we depended on. And then we started selling betas that looked like the early product. And I went around Washington talking to a bunch of people, because they buy a lot of tech and such, and basically got introduced to somebody who was interested. This was at one of the three-letter agencies, and they introduced us to In-Q-Tel, and we had a good conversation, and they ended up investing. Now, they wanted to, they obviously looked a bit at the product and the roadmap and things, and the vision of it. But really, it was just, we got the introduction, and they clearly saw we were a product that could make a key difference in the missions of, largely the three-letter agencies who cared a lot about performance on certain things.
Yeah. Were there specific capabilities or features that the government agencies needed that weren't on your commercial roadmap?
There was one thing that we really did. I mean, there were some things we didn't have yet that were going to be on the roadmap. The one thing we did for the government that was really for them was this feature called rapid data locking. And it's really simple. Imagine you're in some, let's say, foreign country, and you have a bunch of data storage, and the building you're in is being invaded. Whether it's the CIA and the police are coming in to raid it, or whether it's an embassy and you're being invaded and taken over because you're in Iran or something. So normally you destroy all the information and you get out. Now the problem with destroying the information is how do you destroy a hard drive? The Marine guards at embassies were trained like, oh, you put a couple of bullets through the hard drive. I can tell you that any government that wants to can still read the data. They can't spin the hard drive around, but you can take an electron microscope and you can see the magnetic patterns. You can look there's like a video online of somebody on a beach blowing up a disk array with C4. And you can still pick the platters up and read the data. It's hard to destroy it when you actually want to. And so the rapid data locking, the idea was it was like a special USB key you stuck in the back of the array, and if you simply pulled the power and pulled the USB key and destroyed it, everything was encrypted and there was no way to read any of the data. And so that would facilitate rapidly evacuating a building, leaving behind the array, and it's still secure. Same thing if you were thinking of a forward deployment with the Army or the Navy or the Air Force. Like, oh, you put it on a plane, the plane's going down, you just destroy those USB keys and nobody can read any of the data.
How did you think about, also just going back to the competition question, incumbents like EMC that had decades of long relationships with government agencies, and how did you convince the agencies to sort of rip out the proven infrastructure and then take a risk on a startup?
Well, okay, so most of these places are always looking to get an edge. So they want to find something better, so they're willing to try stuff. It's one of the things that a lot of parts of the government are very willing to do. I mean, don't go to the Social Security Administration and try to sell to them if you want them to try something new, but you go to Department of Defense or any of the agencies or things like that. They always want an edge, so they're always looking to experiment. So that part's easy, right? Now you have to prove to them that you're as reliable and trustworthy and that you have actual key big benefits. That's another thing to recognize, that the companies that have been around a long time, they have a deficit too. So some of our competition has 30 years of software that they have written, and so changing their product, adding features to their product or doing something radically different is very hard. A company that wrote their software for hard drives for 30 years has 1,000 unspoken assumptions in that software about a hard drive. And so it's very difficult for them to completely change it for flash without rewriting it, which throws away what they think of as their biggest edge. And to give you one example, one of our largest competitors on one of their products still has code written for Windows 97 in it. Inside the kernel of this high-tech modern storage product, Windows 97, which nobody in Silicon Valley thought was high-tech when it came out, let alone now.
Maybe we could talk a little bit about ransomware as well. And I think these days government agencies and also businesses are prime targets for nation-state cyber attacks. And how does Pure Storage's ransomware recovery approach differ when the threat actor isn't maybe just like a criminal gang, but a more sophisticated adversary with nation-state resources, like in many ways like unlimited time, resources, sophistication?
So if I have physical access to the machine, it's like, sorry, I can destroy it, and there's nothing you can do about it. If I don't have physical access, then, so we have what we call safe mode snapshots. So a snapshot, imagine it's like taking a picture of your data, right? You take a copy of your data, and it's designed to be a point-in-time copy. And a safe mode snapshot is simply one where there's no way for the product itself to destroy the data. Okay, so normally you go into you have a laptop, you go delete a file, and then it goes into your little trash can, and then you say empty the trash can, and it's gone. But with a safe mode snapshot, you can't do that. You can't take it out of the trash can. And the only way to really protect yourself against ransomware is to take the safe mode snapshot, and then actually to copy it to some other place. So if you actually lose the physical access to the machine, you have another copy somewhere. And whether it's a nation state doing it, and remember, by the way, so people are trying to steal the data, people are trying to destroy the data. So that protects against people destroying the data. People stealing the data, humans are always the weakest link. So if you're trying to steal data from me, you're not going to go and like get around my encryption and read it off the medium. You're going to figure out how to steal my credentials, and then you're going to figure out how to access the data like anyone would and exfiltrate it. And so that organizations have to protect against exfiltration, which gets very annoying for some of their employees because you go to a big bank and they're like, nope, you can't bring your phone into the data center. You can't bring a USB stick. You can't, right? And it's like, that's the only way that they prevent that. And it's a constant battle.
Maybe you could share a little bit more in terms of how Pure Storage scaled from NYSE to other government agencies. Like you guys have now served agencies across space, cyber, defense, health, state, local, education markets. Like how did that come about?
Well, a bunch of time. The government is slow. Okay, so if you're doing a startup and you think, hey, the main thing I'm going to do is sell to the government, either you're selling to an agency that's going to make a quick thing with a great value proposition, or it's going to be slow. They are slow to change. That's why they're the government. And this is true not just of our government, of all governments. Actually, sort of in a funny thing, the first government that ever purchased anything in our product was the city of Davenport, Iowa. And you can actually go back to like early 2012, and they had a city council meeting where they're openly debating, like, are they going to spend the money on us, which is kind of funny. You know, city governments are not the same as federal government or state government. But, you know, when you're going to sell to the government, a lot of it acts just like any large business, except more conservative. So the agencies move fast, the agencies make decisions, the agencies experiment. The rest of the government, it's like you got to build up your credibility in terms, again, of your reliability, your dependability, your ability to service the gear, and all of that. And it's, you know, it's like selling to any large conservative enterprise, just a little slower. One of our sales guys, early sales guys, I went around Washington with him talking to a bunch of customers, and at the end of the trip, he's like, man, if I had to do that every day, I think I'd rather chew my arm off. Because, you know, they're not motivated to like move fast, to make a decision. And so it's hard.
Yeah. Were there other challenges you faced just selling into classified programs or, you know, secure facilities?
You have things like, okay, we don't know where this gear is, so somebody needs to go service it. They're going to get picked up somewhere and go somewhere, and you know they don't know where. Spare parts. Okay, where do we put the spare parts? We're not allowed to know. And if we sell somebody spare parts that they have on site, then, well, what do you do with all the spare parts you get of things? You put it somewhere, and then when you want it, you have trouble finding it. And so spare parts that we put on site are often mislaid, tough to find when you need them. You know, things like, you know, the U.S. government wants to be, their support calls to be handled by U.S. citizens. If they have a bug, I think they're kind of like, do you have engineers from the U.S. working on it, or engineers in, like we have a site in Bangalore, we have a site in Prague. And they want to make sure our engineers that are here in California are working on it. So you have those sorts of things that you have to demonstrate. And then the same is true for other governments. So, you know, we sell to the UK government and they're not like, well, yeah, we want Americans working on everything. No, it's like you got to have UK citizens. And so that's always a bit of a challenge.
So maybe we could talk a little bit about the current wave of AI. Maybe I'll start by just saying, so I think there could be a future where organizations deploy consider it like several AI agents per employee. And this might be sort of one of the biggest tech refresh events in history. And is Pure Storage's infrastructure ready for this scale? Like, what sort of changes are necessary when you need to support thousands of autonomous agents rather than human users? Like, if every company decides to deploy millions of AI agents and create sort of, maybe it's like 2x or 100x or even more increase in the so-called users, and they all have fundamentally different workload patterns. Is Pure's storage infrastructure ready for this? And like, what's different about serving agents versus humans as well?
So I think our infrastructure is pretty ready for it. We're looking forward to it because it should boost our business nicely. The biggest thing with all of that is it's going to put a lot more emphasis on performance and flexibility. Think about any organization you deal with. So you go to your bank and you do something. Well, so they're not going to take all of your account information and everybody else's information and suck it out of all their databases and send it over to some AI thing and spend weeks crunching on it and come up with some AI benefit, right? The benefit's going to happen when you're right there interacting with them and they can change behavior and do things, either to get more business from you, to make things more relevant to you, to provide better service, et cetera. So that means they're going to need to take their existing systems, their existing databases, their existing applications, and have them running on the data, but also add all the load from all these agents. So it means the performance needs are going to go up a lot. That's something that's really good for any all-flash storage. The biggest difference between flash and disk is twofold. You have a lot more performance, and the geometry of the accesses doesn't matter the same way, right? A disk was a physical device. It had platters, they would rotate. You had to move the read heads around. So when you did one access, the performance was very dependent on, was the next access the very next block, or was it like, did I have to move the disk heads over? And it made a gigantic difference. With flash, you don't have that. So flash really benefits from AI and from the more disparate use, but all the applications will need to scale up in their performance. And so that should be really good for our business as businesses start to use it. And meanwhile, every business is out there hunting for the benefits in AI. We are too. We have 100 different initiatives internally using AI all over the place. And some of them will work out great for us, and some of them will be a nice experiment that didn't work out. It is over the next 10, 15, 20 years going to completely revolutionize society as a whole.
Maybe we could talk about, call it the persistent memory requirements of these AI agents, where you kind of need persistent long-term memory storage, not just for conversations, but perhaps also for governance, explainability, and kind of like logging everything so that you can explain why an agent sort of reached a conclusion. How does flash economics work when you need to retain, call it like years of agent decision logs?
Yeah, that's going to be interesting because that's going to generate so much data that I don't know how people are going to store it. I mean, so if you think about data already, the data from your financial transactions and things like that is already dwarfed by the data from billions of people with cell phones taking photos and videos, and all the text messages, and then all the social media stuff, and then everything they generate to try and connect all that and make it better. And when you start imagining that, you're going to drive a car around with driver assist, and whether you drive or it's auto drive, that car's going to want to record a whole bunch of sensor telemetry so that later we can figure out exactly why it decided everything. That's like tons and tons and tons of data. And so, I know people are talking about storing this stuff, but I think when they actually add up how much data it is, they're going to have to figure out how they don't store everything, but store only parts of it, because it'll be a decade before there's enough storage capacity to potentially store all of that stuff, which is great for the storage industry.
Yeah. So maybe just from a infrastructure economics perspective, it feels like GPU budget is eating up a lot of these enterprises' budget, where like GPUs consume more power than CPUs, and they're really dominating infrastructure budget that perhaps maybe leaves less share of the wallet for storage. Like, how do you think about selling storage to maybe more budget-constrained customers who just maxed out their credit cards on GPUs?
So that is a challenge, and if you think back to like the early 2000s, again, I know for many of you that's before you're really paying attention to any of this, but like you had digital cameras. And sort of the joke was, hey, if I go to the store and buy a digital camera, by the next day it's obsolete because they've come out with 3 new models. And you see that with the GPUs. They're advancing them so rapidly right now. So I think most organizations, the smaller organizations, should all actually be renting out GPUs so that they're staying up to date better. That will actually lead to lower spending on it, as well as more cost-effective spending. For the large companies and the GPU clouds, yeah, they're going to go buy tens of thousands, hundreds of thousands of GPUs and use those and get enough usage out of them to pay for it. But it's also true that we're in a stage where everybody's so afraid of missing out on the gold rush that they're overspending. And I saw somebody like a year ago, and it's still valid, said, I've never seen so many companies dying to spend $50 million to save $50,000, because the AI isn't paying off yet. Now the thing is, it will pay off, right? It's just a question of, it's not going to pay off in the next year, it's going to pay off in 5 years or in 10 years. And most people need to think a little bit more long-term than that. Or like that, I should say.
Yeah. I was reading up on some of Pure's also 85% energy efficiency, and with some of these new NVIDIA systems requiring 125 or 120 kilowatt per data center rack, and a lot of customers don't have that, and power is that primary constraint. Like, how does Pure's energy efficiency translate to kind of real AI cluster economics?
Well, so most people these days budget their data center in watts more than dollars, especially if you're thinking about AI. And so it's all about, I have a data center, it has a limited amount of power coming into it, how can I get the most GPUs in that? And we actually help a tremendous amount with that because what we're doing, the flash modules that we sell, they're larger than hard drives, they're more energy efficient than hard drives, and because they're larger, you put less systems around them. So you end up having a ton less equipment, not just the flash versus the hard drive, but all the network ports to support it, and switches to support it, and servers to support it. And we have a number of very large sales that we've done where really it's been about like, I'm out of power in my data center. You want to talk about expensive? Go get PG&E or your local thing to dig a trench a mile down the road to put in a new power line, and we got to put a new substation here, right? And you can't get it done, and it takes years to get it done. And so when you can save people that energy to let them do a lot more with the data center they have, especially in more built-up environments where it's harder, it's gigantic. Now you also see these like multi-gigawatt data centers being built in the middle of nowhere. They're budgeted in watts, not in dollars of equipment for the hyperscalers. And so, they've, when we've talked to them, calculated massive power savings that is very meaningful. And most people don't realize this. Storage is generally, it's like the second largest consumer of power in your data center. It's probably 25%, 30% of the power in your data center associated with storage. So if you cut that down a lot, you just added a lot of available power for doing other things.
Yeah, yeah. It seems like the conversations are shifting from storage costs to more like how do you enable more AI capacity?
No,
as well.
that's all about that.
Yeah. Maybe another trend we're seeing is a lot of organizations moving AI workloads back to on-prem data centers, maybe like call it like better cost controls, risk management considerations. Is this creating a second wave of opportunity for Pure? And is this like a real opportunity or is it just hype? Like are customers actually buying on-prem storage again or are they still mostly in cloud? And also just like what's different this time compared to what was happening in sort of the 2000s, 2010s data center build out?
Yeah, so about 10, 12 years ago, we would get a lot of people who would say, everything's going to move to the cloud. Nobody's going to have on-premise data centers. And it doesn't make sense for a variety of reasons. Could you imagine the hospital here saying, we're in the cloud. Guess what? Our network connection to the cloud's down. Sorry, all service has to stop. They can't do that. A factory, they're not going to depend on a network connection being up to run that factory. You shut down like a semiconductor fab, and it can take you a month to get it fully started up again. Okay, so they're not outsourcing things like that, airports, et cetera. So there was a whole bunch of stuff that was never going to the cloud. But the cloud, it's a tool like anything else. It has problems and it has benefits. And the people who were saying everything's moving to the cloud were not thinking of the problems. And they also had a misunderstanding of the benefits. For example, we have a couple of services where we provide our software to run a storage service in the cloud on the cloud infrastructure for customers. And it allows them to sort of run the same way in the cloud that they run on-prem and to move stuff seamlessly back and forth. And we had a very large customer who recently, they were in the eastern region of one of the cloud providers. They're like, oh, we need like 100 more VMs. We're like, oh, no, there's no more infrastructure in this thing, right? You go back 10 years, 12 years, and the clouds were growing so fast, they just kept buying so much equipment ahead, they had what appeared to be infinite burstability. But now their growth is a lot slower, so they buy a lot less equipment ahead, so they actually run out of capacity at times in regions. And everybody used to think, oh, I'll go to the cloud, it'll solve all my problems. No, it just gives me a different set of problems. So the right answer, which you see people going towards, is I have some things on-prem that are generally my mission critical things that have to run, and I have other things in the cloud that are burstable, flexible, more maybe my R&D that if it's down a little bit, it doesn't impact my customers, and they have a balance. And that's the right answer. You have tools at each place. Now, if you're a startup, do everything in the cloud. Do not waste a moment as a small startup like doing stuff on-prem. But when you're a larger organization, it is so expensive to be in the cloud, you put some things in the cloud and some on-prem.
Is Pure Storage doing anything to win these sort of cloud repatriation deals or?
Well, so a lot of it is taking advantage of things like our Pure Storage Cloud offering, which is on Azure, or our Cloud Block Store that's on Amazon and things. We're trying to enable people to seamlessly, to use the cloud more efficiently. And this isn't equipment we're putting in the cloud. This is software that runs on the cloud infrastructure. We're trying to let them use the cloud more efficiently and seamlessly share and move what they want from cloud to cloud or from cloud to on-prem or on-prem to cloud. And that gives them, again, agility. And as your business changes, having agility in your IT is really valuable, and that's in effect what one of the things we're selling.
So I guess final question for me is AI keeps evolving from transformers to diffusion models to kind of whatever comes next. And you're someone who's spent initially 20 years optimizing for rotational disks sort of traditional hard disk drives at Veritas, and I mentioned in the intro remarks just like your work as the primary architect for Veritas Volume Manager and file system, and then you reimagined everything for Flash with your work at Pure Storage. What's sort of the next fundamental shift you're preparing for in AI storage?
It's really what I was talking about before, just scaling and flexibility, right? AI is evolving so fast that if you ask me what will it look like in 18 months, I really can't tell you. I mean, I could make up an answer and maybe I'll get lucky and be right, but I'm probably wrong because it is just changing so fast right now. And so the biggest thing that everybody needs is the ability to adapt. Those that will be able to adapt will thrive, and people that can't adapt, organizations that can't adapt, will die. And that's the biggest focus. We're trying to bring increasing optionality, agility, flexibility to all of our customers. We do it with our hardware. One of the things that we've done from day one is we have this model called Evergreen, and you buy a product and you do plug and play swaps non-disruptively, don't take the product down, so you still have your storage service all the time, to newer, better hardware. And so you can change the product, you can scale up, you can scale down. You change the software, all non-disruptively. And that gives people the ability to, buy what they know they need now, and then as their needs change, to alter it. And that is incredibly valuable in an environment that's changing so fast. I mean, I personally lived through the whole internet revolution. This is going like 10 times faster.